Today's lesson on the Monday the 11th of January is we're going to look at surds. Now, you might remember that we did look already at surds briefly before the Halloween break, but we will go back over from the start so that we can do the harder questions that we haven't seen yet. So just to tell you how this lesson's going to work, I don't need you to upload any work. I'm not going to do a Google form or anything like that. What I want you to do is watch the video. Watch me go over some examples. I'll give you time to hit pause and try some questions, and then you can see just if you've got those questions right. So just looking at the specification, we're looking at the highlighted part here, but just the first part of that. So simplify numerical expressions involving surds. That's what we're going to be doing. We're going to be simplifying. Then moving on to tomorrow or the next day, the rationalization of the denominator. So that's the next exercise, but for now we're just going to simplify surds. So before we simplify, we need to know the rules, and here are the rules of surds. So the first one there, root a multiplied by root a is equal to a, and just applying that with a number, root 3 by root 3 is equal to 3. So the square root of something multiplied by itself will give you that number. So root 11 times root 11 will give us 11. Second rule, root a times root b. So you have two different numbers underneath the square roots, you just multiply them together. So root 2, square root of 2, multiplied by the square root of 4 is equal to the square root of 8, because 2 4s are 8. The third one, if you have a fraction, surd in the top, surd in the bottom, a and b, you can just do a divided by b. So the square root of 10 divided by the square root of 2, you can say that that's the same as the square root of 10 divided by 2. So that's the same as root 5. Fourth one looks complicated, but if I just read it out, a root b plus c root b, and that's what it's equal to. I think it's easier if you just look at the example. So 2 root 3 plus 5 root 3, they are both in terms of root 3. So you have 2 and then you add on another 5. So you just collect like terms, just like in algebra, 7 root 3. So there are the rules, let's apply them. So let's look at, these are just the textbook questions on surds. And these questions are just all simplifying really. There's no rationalizing, so that'll be the next exercise. So if I look at the first question here, and just simplify surds by using this rule here. So root AB is equal to root A times by root B. So you're separating a multiplication, a number underneath the surd, you're separating it into two separate surds that are being multiplied together. Now, whenever we do that, we want to make one of them a square number. So we're looking for factors of a number. We're looking for two numbers multiplied together to give us, in this case, 28. So question 1, we're looking two numbers that multiply together to give us 28. But we want one of those numbers to be a square number. And there's our square number there, 4. And if we multiply that by 7, we get 28. 4 7s are 28. Now, why have we made sure that one of them is a square number? Because if you have the square root of a square number, you can get rid of the square root sign. Root 4 is 2. So the square root of 28 can be written as the square root of 4 times the square root of 7, which can be written as 2 times the square root of 7. So having a look at the next one there, what two numbers am I going to put here and here? Well, I want two numbers that multiply to give us 63, and one of those numbers has to be a square number. So the two numbers are 9 and 7. And because the square root of 9, because we have the square root of 9, that means we can change that to 3. 3 times root 7, you just write as 3 root 7. So that's 1 and 2 done. I'm going to skip 3 and 4 and just look at 5. 5 has a number before the square root, but just take that square root of 40 and split it up into two separate numbers, two numbers that multiply together to give us 40. So that root 40 I've changed into root 4 times root 10. Why root 4 by root 10? Because we can simplify root 4 to give us 2. And once we do that, well, that means we're going to have 3 multiplied by 2, which is where this 6 comes from. So overall, the answer to question 5 is 6 root 10. So what I'm going to get you to do now is I'm going to get you to pause the video and have a go at questions 1 to 10. And then I'll show you the solutions once you unpause. So the answers to all of these questions then. Question 1, root 28 is 2 root 7. Root 63 is 3 root 7. Root 125 is 5 root 5. Root 600 is 10 root 6. 3 root 40 is 6 root 10. 4 root 50 becomes 4 times root 25 times root 2. But this bit, 4 times root 25 becomes 20, so it's 20 root 2. Root 216 rated as 36 by 6, and you're left with 12 root 6 as an answer. 3 root 112 becomes 3 times root 16 times root 7, which becomes 12 root 7. Question 9, the square root of 108, express that as the square root of 36 times the square root of 3, which is 6 root 3, but you're dividing it all by 3, 6 in the top, 3 in the bottom. Leaves us with 2 root 3. Root 50 is root 25 by root 2, which is 5 root 2, but you're dividing by 5, so you're just left with root 2. So let's move on to the next question, set of questions, question 11, where you're simplifying and you have an additional operation, multiplication or division, or maybe even both later on. So just look at the first question, root 8 multiplied by root 50. First thing you want to do is simplify root 8, and then simplify root 50. So root 8 is 4 root 2, which becomes 2 root 2. Root 50 is 25 root 2, which becomes 5 root 2. So we haven't performed the calculation yet, we haven't done the multiplication. So this is what we need to perform. 2 root 2 multiplied by 5 root 2. So 2 root 2 is just 2 multiplied by root 2, and we're multiplying that by 5 times root 2. All of these multiplications, it doesn't matter what order you perform them in. If I do the 2 by 5 first, then root 2 by root 2 second, 2 by 5 is 10, and root 2 by root 2 is 2. So our final answer is 20. Now you don't have to do all of this working out. You should get to a point where you can just look at what's in the box here and say 2 5s are 10, root 2 by root 2 is 2, 10 2s are 20. So if I rub all that out and try and do the next one, I'll just give you the answer actually. So 2 by 5 is 10. Root 2 by root 2 is 2. So the answer is 20. So let's do part B. So square root of 75, change that to 25 by 3. That's a division this time. Root 27, well that can be square root of 9 times square root of 3. So what we have here is we have 5 root 3 divided by 3 root 3. So I'm going to actually write it as a fraction, top divided by bottom, so that you should see that the root 3's cancel and you're just left with 5 over 3. So at this point, have a go at the rest of that exercise. So just pause your video and try questions C to F. See how you get on. So the answers to question 11, some of these were tricky enough. First one was done, root 8 by root 50 gives us 20. Second one, root 75 divided by root 27 gives us 5 root 3. The third one, root 32 multiplied by root 8. So change root 32 into 16 root 2 and root 8 into 4 root 2. So that becomes 4 root 2 times by 2 root 2. 4 2's are 8, and root 2 by root 2 is 2. Multiplying together you get 16. D is a funny one. The square root of 15, you don't normally change it because there's no square number goes into it, so we'll leave it as it is for now, root 15, and we'll change the root 27 into root 9 by root 3, so that's 3 root 3. But then what I'm going to actually do is, so there's our root 27, 3 root 3. I'm going to write root 15 as root 3 multiplied by root 5, because at this point, hopefully you can see that we have all of these things multiplied together. 3 times root 3 times root 3 times root 5. Now, these two things here, root 3 by root 3 gives us 3. So that becomes 3 times 3 times root 5, which is 9 root 5. Part E is the same numbers, root 15 divided by root 27 this time. So what I have done is written root 15 as root 3 root 5 and 27 as root 3 root 3. And what you should see, you have root 3 in the top and bottom, they cancel. So root 5 in the top, root 3 in the bottom. And for part F, root 10 multiplied by root 12. What I've decided to do this time is just multiply them together, get the square root of 120 and express that as 2 root 30. So the square root of 120 is the same as square root of 4 times square root of 30, so that's 2 root 30. But then remember your rules of surds, top divided by bottom. So if we have root 30 over root 15, that's the same as square root of 2, because 13 divided by 15 is 2. So that's where we get our 2 root 2 from. On to question 12 now. So these operations are not multiply and divide, but add and subtract. So we will need to express each of these surds. Well, we need to simplify them and see if they can be collected together. So the square root of 18, let's look at it first. That's root 9 root 2. And the square root of 72, well, that is root 36 root 2. Remember, you have to take out the biggest square number. So then that's 3 root 2 plus 6 root 2. And because they're both in terms of root 2, you can have a combination, add them together to get 9 root 2. So have a go at, if I just tell you to pause your video, have a go at B, C, D, E and F. So the answer is question 12, where you're adding and subtracting then. So part B, 4 root 3 plus root 12, simplifies to give us 4 root 3 plus 2 root 3. So the answer is 6 root 3. Part C, you should get 25 root 2 plus 4 root 2 to give us 29 root 2 as the answer. D, check the working I have here, and you should get 3 root 5. E, there's the working out, and the final answer is 8 root 3. And the F, check out the working out and see if you got 7 root 2. So question 13 and 14 I'm just going to talk you through. If x is 5 plus root 2 and y is 5 minus root 2, simplify x plus y. So you're just collecting like terms, just being careful that you have negative signs, positive signs and whatnot. We'll have a look at A and B there. For A, when you add them together, 5 and 5 is 10, root 2, take away root 2, disappears. For B, 5 subtract 5, they disappear. Then root 2 subtract minus root 2 gives us 2 root 2. But the questions C, I'm just going to leave out because I would rather look at it whenever it comes up in question 15. Next one, question 14, x plus y. Same again, you're just collecting like terms, being careful for the negative signs. 7 plus 5 is 12. Root 3 plus a minus 2 root 3 gives us minus root 3 in our answer. X subtract y, well then 7 subtract 5 is 2. Root 3 subtract a minus 2 root 3 gives plus 3 root 3. And C and D we'll just leave it because I want to come across that whenever we look at question 15. So these are the last few questions I want to get you to do today. They're expanding double brackets with surds, and I'm just going to do the first one and let you do the next three. So if we have a bracket squared, well then we're going to have that bracket multiplied by itself. Now from there, whenever you multiply out two brackets in algebra, you have your own method. You have FOIL, bird speak, but I'm going to try and encourage you to use breaking the brackets. So just in a different colour here, this bracket, root 3 plus 5, I'm going to write in red, root 3 plus 5, but I'm splitting it up because after the root 3, I'm going to write the second bracket. So there's our second bracket repeated twice. It's being multiplied by the two terms that are in the first bracket. So then, root 3 times root 3 plus 5 times root 3 plus another 5 times root 3 plus 5 times 5, which is 25. So root 3 times root 3 is 3. 5 root 3 plus another 5 root 3 is 10 root 3, and we're adding it on, and then we're adding on 25 as well. So nearly done. We have 3 here, 25 there, so altogether that's 28. We have a 10 root 3 at the start, so 10 root 3 plus 28. So for each of these questions, B, C and D, you're going to be using your reckon brackets hopefully, but if you want to use FOIL or BirdSpeak, whatever method you have for multiplying two brackets out, and then you're collecting like terms and using the rules of Surds, so you'll be able to tidy up everything. So have a go at B, C and D. Pause the video, and then I'll go with the answers whenever you hit resume. So for part B, you have one bracket multiplied by another, 2 minus root 3 times 2 plus root 3. So I split the brackets 2 times the first bracket, subtract 3 times the second bracket, multiplying it all out. 2 2s are 4, 2 root 3 here, minus 2 root 3. And then this last part, you have root 3 times root 3, but one of them is a minus, so you're doing, so it is a subtract root 3 root 3. Now 4 plus 2 root 3, subtract 2 root 3, they go away, they cancel out. And then subtract root 3, well that's the same as 3. So our final answer is just 4 take away 3, which is 1. Part C, it's the same bracket multiplied by itself, 6 minus 2 root 3, squared. So I have split the first bracket, 6 and minus 2 root 3, and multiplied by the second bracket. 6 6s are 36. 6 times minus 2 root 3 is minus 12 root 3. Minus 2 root 3 times 6 is minus 12 root 3. And the last one, two negatives make a positive. Minus 2 root 3 times by minus 2 root 3 is a positive 4 root 3 root 3. So this last part becomes 4 times 3. Because root 3 multiplied by root 3 is 3. So then 36, this middle bit, subtract 12 root 3, subtract 12 root 3, well then that just comes together. Subtract 24 root 3, and then tidy it up, you have two numbers. 36 plus 12 is 48. So 48 subtract 24 root 3. The last question is two different brackets multiplied together, but same thing. What I've done, split the first bracket, 2 root 7 plus 5 multiplied by the second bracket. So 2 root 7 times 3 root 7 is 6 times 7, which is 42. 2 root 7 times minus 2 is a minus 4 root 7. 5 times 3 root 7 is 15 root 7. 5 times minus 2 is minus 10. So just these middle two terms, collect them. So a minus 4 root 7 plus 15 root 7 is 11 root 7. 42 here, subtract 10. Final answer is 32 plus 11 root 7. So that's the end of the lesson. You've nothing to submit today, but from tomorrow we'll start doing some Google form quizzes, and we'll start getting you to take some pictures of your work and upload them. But that's us for now.